Hello dears, this is the second part of the topic, Divergence Theorem. In this lecture, we will discuss some problems regarding Divergence Theorem. Here is a question which can be solved by using Divergence Theorem. So the question is, if the vector field f equal to xyi plus y square z into j plus z cube into k, evaluate the surface integral over s f dot n ds, where s is the unit cube defined by 0 less than or equal to x less than or equal to 1, 0 less than or equal to y less than or equal to 1, and 0 less than or equal to z less than or equal to 1. So here our s is actually the unit cube defined by these, that is x varies from 0 to 1, y varies from 0 to 1, and z varies from 0 to 1. So നമ്മുടെ s എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ ഒരു ക്യൂബാണ്. Like this. So here x varies from 0 to 1 and y varies from, if this is this, so x varies from 0 to 1, y varies from 0 to 1, and z varies from 0 to 1. Right, this is x axis and this is y axis and this is z axis. So x varies from 0 to 1, y varies from 0 to 1, and z varies from 0 to 1. So uh, here we have to find the surface integral. So here for this surface we have 6 sides. Okay, so if we are trying to do it directly, we have to split the surface into s1, s2, s3, and this is s4, this is s5, and this is s6. അപ്പോൾ ഈ ഒരു സർഫസിനെ നമ്മൾ 6 ഭാഗങ്ങളാക്കി തിരിച്ചിട്ട് normally surface integral over s is equal to integral over s1, surface integral over s2, etc., surface integral over s6 ഇങ്ങനെ ചെയ്യണം. But by using divergence theorem നമുക്ക് ഇതിനെ ഒന്നുകൂടെ ഈസി ആയിട്ട് ചെയ്യാൻ പറ്റും. That is by divergence theorem we have surface integral over s f dot n ds is equal to triple integral over d divergence of f dv, where d is the solid bounded by the surface s. അതായത് ഈ സോളിഡ് ഈ ക്യൂബ് എന്നതിൻ്റെ അകത്തുള്ള പോർഷനാണ് എന്ന് പറയുന്നത്, അല്ലെങ്കിൽ മൊത്തം പോർഷനെയാണ് ഡി എന്ന് പറയുന്നത്. ഓക്കെ, സോ നമുക്കിത് ഇൻറ്റഗ്രേറ്റ് ചെയ്താൽ മതി. സോ ദിസ് സർഫസ് ഇൻറ്റഗ്രൽ ഈസ് നത്തിങ് ബട്ട് ദിസ് ട്രിപ്പിൾ ഇൻറ്റഗ്രൽ. സോ ഈ ട്രിപ്പിൾ ഇൻറ്റഗ്രൽ ഇൻറ്റഗ്രേറ്റ് ചെയ്യാൻ ബുദ്ധിമുട്ടൊന്നുമില്ല. ഡൈവർജൻസ് ഓഫ് എസ് ആദ്യം കണ്ടുപിടിക്കാം. ആൻഡ് ഡിയുടെ വേരിയേഷൻസ് എന്ന് പറയുമ്പോൾ എക്സിൻ്റെയും വൈയുടെയും സെറ്റിൻ്റെയും വേരിയേഷൻസ് ഓൾറെഡി ഹിയർ വി ഹാവ് 0 ലെസ് ദാൻ ഓർ ഈക്വൽ ടു എക്സ് less than or equal to 1, and y varies from 0 to 1, and z varies from 0 to 1. Okay, so for this we need to find divergence of f. Okay, so here we are given that f is equal to this. Okay, so since f is equal to xyi plus y square z into j plus z cube into k, we have divergence of f is equal to del dot f, which is equal to del is I dou by dou x plus j dou by dou y plus k dou by dou z dot f is xy into I plus y square z into j plus z cube into k. Clear? So which is nothing but dou by dou x of this xy first component plus dou by dou y of the second component is y square z plus dou by dou z of the third component z cube, right? Therefore which is equal to dou by dou x of xy is y plus dou by dou y of y square z is 2yz plus dou by dou z of z cube is 3z square. So this is nothing but del dot f or divergence of f. So from this divergence theorem we have one implies the required surface integral is f dot n ds, which is equal to this triple integral. So this triple integral can be written as integral x from okay, x varies from 0 to 1, y varies from 0 to 1, and z varies from 0 to 1. Okay, so we can write this z varies from 0 to 1, y varies from 0 to 1, and x varies from 0 to 1. The integrand is y 2yz plus 3z square. This is divergence of f into dx dy dz. So limits എല്ലാം constant limits ആണ്. So directly we can integrate. So first first we are integrating this inner integral. So integral 0 to 1 y from 0 to 1. And what about the integral with respect to x? So we have yx plus 2yz into x plus 3z square into x. So here actually this is independent of x, right? So we can directly write like this. We can take y x outside. Or these are constants, y plus 2yz plus 3z square into x. The integral is x. That is with respect to x, we are integrating with respect to x. So these are constants. Okay, this term is constant. So integral is 0 to 1. So x varies from 0 to 1. Then dy dz. So applying this limit, we will get 1 minus 0. So this is self. So z varies from 0 to 1. Y varies from 0 to 1. Y plus 2yz plus 3z square into 1 minus 0. Okay, dy dz. Now next we have to integrate this with respect to y. So this is equal to integral z from 0 to 1. Integrating with respect to y, we will get y square by 2 plus 2y square by 2 into z, that is y square itself, plus 3z square into y. Okay, integrating with respect to y, so keeping x and y as constants. So here we have only sorry, x and z as constants. So integral of y is y square by 2, integral of 2yz, so 2z is constant, and uh, yeah, here is a mistake, I think z into, yeah, z into integral of 2y, that is y square by 2, so z into y square by 2, so z into y. So 3z square is a constant, then the integral will be y from 0 to 1 into dz. So integrating this, applying this limit, we get 0 to 1. So this is 1 by 2 plus z plus 3z square, then minus 0 minus 0 minus 0. So dz. So so integrating again with respect to z, we get z by 2 plus z square by 2 plus 3z cube divided by 3. So z cube from z is equal to 0 to 1. So this is equal to 1 by 2 plus 1 by 2 plus 1 minus 0 minus 0 minus 0. Okay, so this is 2. So the value of the surface integral is nothing but 2. Clear? So here we have converted our surface integral into this triple integral by using the divergence theorem. Next question we can discuss is example 2. Find the outward flux surface integral over S f dot n ds of the vector field f equal to x cube I plus y cube j plus z cube k, where S is the sphere, x square plus y square plus z square equal to a square. Here we have S is this sphere, x square plus y square plus z square equal to a square. That is a sphere with the center, origin, and radius a. Okay, so let D be the solid region bounded by S. That is bounded by the sphere x square plus y square plus z square equal to a square. Bounded by S, that is x square plus y square plus z square equal to a square. So D എന്നുള്ളത് ഒരു ബോളാണ്, ഒരു സോളിഡ് ബോൾ അല്ലെങ്കിൽ ഒരു സോളിഡ് റീജിയൻ ആണ് വിത്ത് center at origin and radius a square. So this is the S, and D is this uh, region bounded by this S, right? So so to find this surface integral, we can convert this into a triple integral by using the uh, divergence theorem. So for that we have to find first the divergence of f. Okay, so now divergence of f is equal to del dot f, so which is, we know that dou by dou x of x cube, that is 3x square, plus dou by dou y of 3 y cube, that is 3y square, plus dou by dou z of z cube, that is 3z square, right? Therefore by divergence theorem we have surface integral over s f dot n ds for the outward flux is equal to triple integral over d divergence of f dv, which is nothing but triple integral over d divergence of f is 3x square plus 3y square plus 3z square. So we can take 3 outside from that. So 3 into x square plus y square plus z square into dv. Okay. So to find this triple integral, it's better to convert this uh, into spherical coordinates from this Cartesian coordinates. Okay, so we can write this as triple integral over d. The spherical coordinates, we know that it can be converted by using this. X is equal to rho sine phi cos theta, y equal to rho sine phi sin theta, and z is equal to rho cos phi, and dv can be replaced by uh, uh, rho square sine phi d rho d phi d theta, right? Rho square sine phi into d rho d phi d theta, and by applying this we have x square plus y square plus z square is nothing but rho square, right? So what about the variations of rho, phi and theta? So this is a sphere. So we have a rho varies from 0 to a, because this is a sphere with radius a. So rho varies from 0 to a. Phi varies from 0 to pi, and theta varies from 0 to 2 pi. Then we'll get the entire circle, entire sphere, right? This pi varies from this to this, and theta varies from 0 to 2 pi. Okay, so phi varies from 0 to pi. So we'll get an entire sphere. So we can write this as uh, this is 3 into rho square x square plus y square plus z square equal to rho square into dv. Dv is rho square sine phi d rho d phi d theta. So now we have to apply the variations of rho, phi and theta. So we have theta varies from 0 to 2 pi, phi varies from 0 to pi, and rho varies from 0 to a. 3 into rho power 4 sine phi d rho d phi d theta. Clear? So this is equal to, first of all we can integrate with respect to rho, that is because this inner integral is with respect to rho. So we can take 3 or 3 and sine phi outside with respect to we are taking integrating with respect to rho. So theta varies from 0 to 2 pi, phi varies from 0 to pi. Now we are 3 sine phi can be taken outside, and integrating rho power 4 with respect to rho, that is rho power 5 divided by 5 from rho equal to 0 to a d phi d theta. Okay, so this is equal to integral theta from 0 to 2 pi, 5 from 0 to pi, 3 sine phi is here. So integrate, applying this limit, we will get a power 5 minus 0 power 5 divided by 5 d5 d theta. Next, we can integrate this with respect to 5. Here a square is a constant, so we can take it outside. So 3 into a power, so a power 5 divided by 5. This is not a square, this is a power 5. So we can take it outside, and theta varies from 0 to 2 pi. Now integrating this with respect to 5, that is sine phi. Integral of sine phi is minus cos phi from phi equal to 0 to pi into d theta, right? So this is equal to 3a square divided by 5 into we can take minus outside, or we can write this is integral theta from 0 to 2 pi, cos pi is minus 1, so minus into minus 1, that is 1, minus minus plus cos 0 is 1, so this 2 into d theta. So this is equal to 3, that is 6, 2 into 3, that is 6 a square by 5 integral theta from 0 to 2 pi d theta. So this is equal to 6 a square divided by 5 theta from theta equal to 0 to 2 pi. So applying this limit, we will get 6 a square divided by 5 into 2 pi minus 0, right? So we have 12 a square pi divided by 5 as answer. So this will be the required surface integral or required flux, outward flux. As some homeworks, you can do these problems. The first two problems are to verify the uh, divergence theorem. So here for these two problems, you need to find the surface integral as well as the triple integral. And in the problems 3 to 9, we have to use the divergence theorem to find the outward flux, that is to find the double integral of this vector field. Third question is already done in this video. Okay, so you just try to find the solutions of 4 to 9, okay, and 1 and 2. Thank you.